Hey folks, I'm Amit D'Souza, a Kubernetes contributor and CNCF keynote speaker. I'll be speaking about platform engineering at a keynote session at KubeCon China 2025 and would love to connect with you all there. I'm also the founder of Odyssey Cloud, where we make platform engineering practical, secure, and built to last. We have enabled multiple organizations across the globe to modernize and scale their platforms. Today, we are going to walk through platform engineering, and we are going to walk through the different processes, how we currently did it, which is the DevOps ideology, the challenges of standard DevOps, what is platform engineering, and why are we moving towards platform engineering. So you will notice that in the current DevOps ideology, we do have self-reliance and ownership massively. We have a you build it, you run it ideology, which is great, but there's massive limitations on that. We have to have loads of automation in place. And in case if you have bigger companies, there is a possibility that you have separate DevOps team where you have to raise requests, and only post that you will basically be able to proceed down any new infrastructure you require, any new pipelines you require. Ideally, in the current DevOps state, we should have infrastructure as code in place and continuous integration in place. This is going to help you build your applications as you go along, and post that it goes into your testing automation or your testing pipelines, after which you end up with a continuous deployment all the way from dev to production. Once all of this is complete, we should be having monitoring into place, where we ensure that we are monitoring our applications to ensure they are stable and they are available constantly. What are the challenges of these current DevOps practices? What you'll notice, there is a massive overhead for dev teams, as there's a lack of self-service in quite a few of these places. If your current team has self-service in place, you're already on the platform journey. What you'll notice is with that, there is a massive overhead and workload wise for developers if they have to run both the dev and the DevOps. They can't just concentrate on building the best product they have. They also have to think about, hey, can I use Kubernetes for this? Should I be using another type of cloud function? Should I be using a specific cloud platform? What tool should I use for caching, etc.? While some of this might fall under the developer architecture for that application, some of the other tooling, which is more specific to DevOps, is something that the developers would have to learn in this scenario, which normally, if there was a separate team which was dealing with it, they wouldn't have to do so. The next thing is reactive pipelines. Due to the entire process being where you have a separate DevOps team or and the dev team, and potentially if the DevOps and the dev is one and the same, it's all reactive pipelines. Since only one team currently requires a new type of pipeline, they would now go ahead and start building that pipeline. That would affect the agility of the team and would basically affect any timelines with which they need to deliver their product. They wouldn't be able to only concentrate on, okay, let me go and write the best product code I can. I also have to fix up the CI/CD pipelines, or if there's a certain issue, they would have to look into it. The next thing is, in larger companies, you're going to have a lot of code duplication. You'll have multiple teams under multiple departments who are writing the exact same code multiple times, rather than you have this one single piece which can be reused over and over by different teams and different departments, etc. How does platform engineering help in this entire cycle? So if you look here, you see that in your current platform engineering phase, you have multiple cycles. So first thing you do is you identify the challenges. What is the challenges that currently is being faced by your developers, and what are the current DevOps inefficiencies that can be fixed? You then go ahead and build that as a product. So when you start building the platform, you have to build it as a product. Think of always the developers as your clients. And when you deliver any code to them, you basically ideally should be taking client interviews to confirm that it is up to par and you follow the standard agile process, which any developer would before releasing their product out to the end users. During this phase, you're going to be developing either an internal developer portal, or potentially you could provide them an API, CLI. There are multiple options. It doesn't have to be restricted with a beautiful UI always. Post that, you provide them tooling. So once you decide all of these different things, you then realize that you can develop specific tooling for them, and you provide this centralized tooling so that they can go ahead and perform whatever actions they have with the reusable components. One thing to keep in mind when you do this is you ensure that you try and encourage them to give back to the tooling as well. So it shouldn't be a blocker that only the platform team can provide the tooling. The developers should be able to provide some inputs into the tooling as well. They should be able to start contributing to the tooling, and it shouldn't be restricted to only the platform team is going to be creating any tooling. They can give guidelines and they can provide inputs about this is the best way to build it, and definitely approve the PRs and verify that it's exactly how the rest of the tooling has been built. But it doesn't need to be restricted to the platform team. Define responsibilities. This is how that helps, where even if the developers develop this tooling and provide it to you, you can approve it, you can validate it. And if you're happy with how the entire flow is working, then go ahead and approve it and merge it. So now even the developers are giving back to that same platform, which is not only serving them, but other teams and departments within your organization. Lastly and finally, you foster collaboration. So when the developers and DevOps team are not working in silos, they're working together, what ends up happening is you all collaborate together and encourage each other's contributions. You all will constantly wait for feedback from the developers, and the developers in turn will also not only provide feedback, but also at some point in time realize they can start contributing to making this platform better. What are the benefits of all of this? You have improved developer experience. They find onboarding onto a new setup, onto a new platform, or new tools, or a new way of deployment is very simple and easy. Faster delivery and innovation. It helps rapid deployments and using these automated workflows which are in place. You have better reliability and security. Since all of these guardrails are built into the platform, it ensures that the developers can't mistakenly perform certain actions. So for example, if you have write permissions to a storage bucket in dev, in production, this access is not provided to them. It's just a blanket guardrail. It's just a blanket rule which applies to all of your automations which are present in your platform. This ensures that you have better security and reliability in your setup. Lastly and finally, you encourage contributions and collaborations for building this platform. It encourages teamwork, it encourages knowledge sharing, and you'll work together. What's coming up next? So now that we have walked through the entire current platform journey and what was the previous DevOps ideology, we are now going to next walk through how do you start on your platform engineering journey. And post that, we are going to walk through all the platform engineering tools and their functions, be it security. We have used Trivy in such case. Continuous integration can be GitLab. continuous testing can be test queue, and so on and so forth. Thanks for tuning in. I hope this gave you a clearer picture of what platform engineering really is and why it matters. If you're looking to simplify your developer experience, scale your infrastructure, or you just need a partner on your platform journey, that's what Odyssey Cloud does. Please reach out and let's build something together that works for your team, not against your teams. And hey, I'd love to hear your thoughts. What tools are you using? What challenges are you all facing? Drop a comment below and let's get this conversation going. Thank you.